Okay, so here we are in Unit 2, Homework 8. We're supposed to estimate the percent of the square that is shaded. So what part of that square is shaded? Well, if you look at it, this is 1/4, 1/4, 1/4, 1/4. So this whole section here is 1/4 of the entire thing. So 1/4, and then the red is half of the 1/4. So it's half of means times half of the 1/4, it's 1/8. And so if you take 1 and you divide by 8 on your calculator, you get 0.125. That's the decimal. Now how do you change that to percentage? They want percentage. Well, when you take 0.125 and you put a percentage symbol on it, it's like a magnet, I always tell my students. It's got 2 zeros on it, so it pulls the decimal 2 places, becomes 12.5%. So it's 12.5%. So that the red section here is 12.5% of the entire square. So what we're seeing here is the connection between fractions. 1/8, this is 1/8 of the whole square. The decimal, it's 0.125 of the whole square, and the percentage, it's 12.5% of the square. Those are 3 languages: decimal, fraction, and percentage. They're 3 languages in which you can say a portion. It's like me saying 1 and uno, and then 1 in another language. I'm saying the same number in 3 different languages. We're saying the same portion. This red section is the same portion of the whole square. It's 1/8 of the whole square, 0.125 of the whole square, or 12.5% of the whole square. Fraction, decimal, percentage are 3 ways to say a portion. Let's try number 2 down here. Number 2 says 4.03, change it to a percentage. So you take 4.03 and you put the percent symbol, the 2 zeros, pull it 2 places to the right. It's like a magnet, pulls it 2 places to the right. 403, decimal's at the back now. You don't even have to show the decimal. 403%. How about number 3, 22%, change to decimal. Now this one is already it's already got the percent symbol. So where's the decimal? I don't see the decimal. You know where it is, huh? It's at the end. I always say it's like a period in a sentence. Somebody writes a sentence and forgets to put on the period. You know where it goes. It goes at the end. That's the same thing with the decimal. If you don't see the decimal, it's at the end. Now, they want me to take the percentage off. So when you take it off, it's going to go back 2 places. 0.22 is the decimal, which is the same as 22%. Okay, so on 4 part A, they want us to find 9% of 32. Let's just take it directly. 9%, change that to a decimal, 0.09, of means times 32. Boy, my pen is just not getting it done here. So 0.09 times 32 equals what? What is 0.09 times 32? Let me check on my calculator here. It is 2.88. There it is. All right, let's try part B. Part B says 12 is what percent of 48? 12 is what percent of 48? 12 is what percent of 48? Well, let's take it directly as it comes. 12 is means equals. If something is something, if Johnny is 10 years old, then his age equals 10. 12 equals what percent? That's x of 48. That's times 48. How do we now? So that's a little equation with x. The x is the unknown. It's the what percent, and of means times 48. How do we solve there for x? How do we get x alone? Divide by the 48, huh? And boom, x will equal, if you divide 12 divided by 48 in your calculator, you'll get 0.25. Now, is that my answer? Almost. They want it in a percentage. So when you take 0.25 and you put a percent symbol on it, you know it's a magnet, pulls it 2 to the right, 25%. And that makes sense, huh? 12 is 25%, 1/4 of 48. Okay, now on part C, let's take it directly. 12 is equals 20%. Make that a decimal point, 20 of what number? That's our x. So I just made it directly into an equation. So now, how do we solve for x, the unknown? We divide by 0.20. X equals, isn't it 60? And we're done. All right, let's try D. Where's D? D. What is 6% of 59? D. What was it? 6% of 59? Let's take it directly as it comes. What x is equals 6%, 0.06 of 59 times 59. So multiply that, we get 3.54. Okay, so here we have question number 5. Nathan received a 5% raise last year. If his salary is now $23,100, what was his salary last year? Let me rewrite that. So it was a 5% raise. Salary now $20,100. What was salary before the raise? So what was the salary before the raise? Well, what's tricky on this one is the original. Salary before means original salary. When the original is missing, you have to use a special formula. Let me give it to you here. The special formula is you have to take original times 1 plus the percent equals new. Well, why don't we use old and new instead of original? The old times 1 plus the percent equals the new. So I've got to take the old salary. I don't know the old salary. That's x times 1 plus. Here, let me give a little more room here. So the old salary, that's x times 1 plus, what's the percent? 5%. That's 0.05 equals the new. The new salary is $23,100. That's how you do that. So what do we get? X times 1.05 is 23,100, because that's just 1 plus 0.05 is just 1.05. How do we solve for x? Divide by the 1.05. Boom. X equals. So what is 23,100 divided by 1.05? I'm getting 22,000. His old salary was 22,000. So why do we do that 1 plus 0.05 thing? Well, think about whenever you want to take a salary. Let's say we have just $100 salary, and we want to increase it by 5%. What would you do? You would take the 100 times 0.05, and that would just give you $5. And then you would add back the original 100, right? You would take that $5, and you would add back the original 100, and you'd get his new salary is 105. Well, so you need to add the percentage, the 0.05, and the 1 gives you back the original, because 1 times x, 1 times the old salary, just gives you the original. That gives you the 100 back, and then the percentage gives you the other part. So the 1 plus the percentage gives you the whole thing at once. So number 6 here, during a sale, a dress is decreased in price from 80 to 68. What was the percent decrease? Well, this one's easy. You don't have to do that fancy formula I just gave you. Remember, that fancy formula was when the original is missing, or the old. When the old or the original, whatever you want to call it, the first price before the change is missing, then you got to do this fancy formula. Well, This one's not missing. It was 80 was the original price, and 68 is the new price after the sale. So we have the original, so we don't need to use that fancy formula. We can do this one. Just subtract the 68, right? That's $12 off. And so they're saying, what's the percent? Percent is always going to be the part over the original. So it's going to be the $12 off over the original price of 80. So if you divide 12 by 80 on your calculator, you get 0.15. You got to change that to percentage. So move it 2 places, 15%. So it's $12 off, and that's the part of the original, 0.15, change it to percentage, 15%. All right, number 8 here. $270 suit is on sale for 30% discount. What's the sale price? Okay, so do we need to use the fancy formula? It says when the original is missing, use that fancy formula. Is the original price missing? No, we have it. $270 is the original price. They're just asking us for the new price. So I don't need that fancy formula. How do you do a 30% discount? You know this. You don't need some fancy formula. Just multiply by 0.30. What's that going to be? Use my calculator here. I'm getting $81. So that's $81 off, huh? So then you just take the $270 and subtract the $81. And I'm getting $189 is the sale price. So that you already know.